Alright, in this video we're going to look at importing a standard cell library into Cadence. Now we've done this before, but there is a caveat to this. So here we're going to go to Import Spice. I'm going to load a prior view. Alright, now you can see the view loaded. It's a CDL netlist. Everything should be set up correctly. It should want a netlist Spice. There is no top cell or sub-circuit list. We're going to use a reference library of a 28 nanometer process, and we're going to bring it in with spectra, or for spectra. We're looking for device information in spectra. Now in the past we've used a device mapping file, but in this case we're not going to use one because the standard cells use transistors that are available in the library, so we don't need a mapping file, and they don't have any other cells in the library like resistors, capacitors, or inductors that might cause us to need this. Now we're going to output the library into an output library that I have loaded. We're going to make schematics, and we're going to have the device simulation information in CDF or spectra. Nothing else should need to be written or set up at this point. I am going to make a few modifications. For instance, I've already done this for an LVT library. I'm going to do it for an SVT library, so I'll make a few minor changes to the cells that I'm pointing to. All right, and with this, we should be good to go. I'm going to hit apply. This is going to run. It's going to take a while to run, so I'm going to pause for a moment, and I'll come back when this is completed. All right, so the library import completed, and I've opened up one of the standard cells, and if I look at one of the cells, you can see something interesting. It imports just the width and the length of the device, and it does this correctly. The width here is 125 nanometers, and the length is 30 nanometers. But it doesn't update the finger width at the same time. This will be a problem because ultimately we're going to try and trigger an update to these cells, and when this particular process updates the cells, it updates it based upon the finger width and not the total width of the device. And so we're going to have device mismatches when we do LVSs for these cells later on. We can fix this. So there is a cell parameter called WFG that we're going to need to fix. Now, there is a file that you can find in support.cadence.com called ccs invoke cdf callbacks.il. And we're going to add a procedure at the bottom, which is called set WF to W. You can see it right here. And we're going to create a procedure to load the width value into the parameter WFG and then trigger a callback on the parameter WFG later on that will load that parameter into the device. Now we can do this on just a single cell, or there's another file that you can download from Cadence called CCF CDF callback entire lib.il, and it will do this on the entire lib. So we're going to go into the CIW window and load these two files. All right, now that we've loaded the two files into the library, we're going to call the entire lib function. All right, here's the command to call this on the entire function. We're going to load CCS callback entire lib. We provide the name of the library we're performing this callback on, the function that we're running, which is set WF to W, the one that I just showed you. And then we're going to add a debug statement just to make sure that this actually runs. And if we hit enter, you can see that there's already an error. And it probably is because I forgot to add 3 letters here. All right, and if this is running correctly, you should see something that on the screen like is going on here. It's actually going through every cell and invoking the callbacks on those cells. Once this is done, we'll take a look to see if it worked. All right, here's our cell, and we can go now and click on the device, and you can see now that the finger width parameter is equal to the total width parameter, which is what we were expecting, and this will help the cell LVS later on. All right, so with that, we'll go ahead and stop for here, and we'll look at a different lesson next time.